Hello guys, welcome back to lecture series on discrete mathematics. Guys, in our today's video we are going to learn a principle of inclusion and exclusion with the three events. Already I have explained the principle of inclusion and exclusion in my last lecture, and example based on the two events which is I have done in my last lecture. So if you want to see these videos guys, go and check in playlist. So in our today's video guys, we are going to learn one of the important example, maybe similar type of the example which is possible for your incoming in-sem and end-sem exam. So I hope you all have get the concept. Okay, so we are going through the one of example today. Okay, so what we have given here guys, out of 1 to 1000 integers. Okay, so how many integers are given? From 1 to 1000. So I hope you know what is meant by the integers. Okay, yes, 1 to 1000 means we are taking from 1 2 3 up to the 1000. Okay, these are the integers given, and condition on it is how many of them are not divisible by 3, nor by 5, and nor by 7. Okay, that means we have given some sort of a complement, neither, nor, not, such a word whenever coming, that means this gives some sort of the complements. Okay, that means first of all we have to find out the our universal set, and then or the given event, and then we have to find out its complement. Okay, yes, so let's start mathematically, then you will understand how to deal such examples. Okay, so first of all what we have given, total integers. Okay, that means in our entire set, universal set U, what we have given, universal set U, coordinate of set U is a 1000 integers. That means we have total number of 1000 integers. Okay, yes, and 1 to 1000 integers. Okay, that means from 1 to 1000, that means total number of 1000 integers. Okay, how many of them are nor divisible, neither, nor, and 5 by 3 5 7. Okay, so we have these three conditions. First of all, we have to find out the how many integers which can be divisible by 3 5 7. Okay, find out the number of integers divisible by 3 5 7. That is way easier. Okay, that means you have to find out how many elements which divisible by 3, which divisible by 5, and which divisible by 7. Okay, first of all call all the elements by some variables. Okay, so I consider A as number of elements. Okay, I'm calling A event as number of elements divisible by 3. B event, number of elements divisible by 5. And C event, number of elements divisible by 7. Okay, need to remember, so we are calling three events separately first. Okay, yes, so we have total number of integers. Okay, coordinate of U means total integers. These are the two things given in our example. Okay, so using this one we have to find out how many integers neither divisible by 3 5 and 7. Okay, so A means number of element divisible by 3, B means number of element divisible by 5, and C means number of element divisible by 7. Okay, and total number of integer is U. Okay, first of all what we are going to do here guys, we are going to find out first of all the number of integers divisible by 3, divisible by 5, and divisible by 7. Okay, that means we want cardinality of A union B union C. Okay, that means number of integer divisible by 3, again number of integer divisible by 5, and number of integer divisible by 7. Okay, that means we are taking union for all of them, all of these sets. Okay, yes, so union for all of these set, we write coordinate of A plus coordinate of B plus coordinate of C minus coordinate of A intersection B plus coordinate of A intersection C. Okay, coordinate of A intersection B plus coordinate of A intersection C plus coordinate of B intersection C. Okay, here plus minus, again here plus, coordinate of A intersection B, intersection C. Okay, this is our required set. Okay, that what we want here, number of integers divisible by 3, 5 and 7. Okay, that means we want all the union. Coordinate of A union B union C is coordinate of A, coordinate of B, coordinate of C, intersection B, intersection C, B intersection C, and A intersection B intersection C. Okay, that means how you're taking, take all of them individually separate. Okay, take the intersection between them, first two, first, third, second, third. Okay, this one is intersection, and throughout all the intersection. Okay, yes, let's dive into the solution, guys. We'll understand what we want here. First of all, observe the formula, what the values we want here. Okay, we want the coordinate of A. What is the coordinate of A? Coordinate of A means number of element divisible by 3. That means 1000 divided by 3 is the coordinate of A. Again, coordinate of B is number of element divisible by 5, means 1000 divided by 5 is here, and coordinate of C means number of element divisible by 7, that means 1000 divided by 7 over here. That is the coordinate of A, coordinate of B, and coordinate of C. Okay, after that, coordinate of B, A intersection B. A and B, we want the intersection between A and B. That means 1000 divided by 3 multiplied by 5, so you will get the coordinate of A intersection B. After that, coordinate of A intersection C, 1000 divided by 3 multiplied by 7 is coordinate of A intersection C, and B intersection C is 1000 divided by 5 multiplied by 7. Okay, which is a coordinate of B intersection C. And A intersection B intersection C means 1000 divided by 3 multiplied by 5 multiplied by 7. So all these are required value. You have to find it out and replace over here. You will get the required answer. Here in our next page, guys, I solved the next part here. Coordinate of A. Here 1000 by 3, the integer which divisible by 3, that means total in our set 1000 divided by 3. But you can see, guys, you will get some amount which is in a fraction. Okay, but in a logic we can understand some fraction part can be neglected. Okay, it is like a point. Okay, nothing matter with this. So 1000 divided by 3, we are taking 333 only. Okay, and coordinate of B 1000 divided by 5. Okay, which is a 200. Okay, coordinate of C 1000 divided by 7 is 143. Okay, again the element which is divisible by first two A and B, which is the element which is divisible by 3 and 5, which is 1000 by 3 and multiplied by 5, which is 66. The element which is divisible by 3 and 7 is 1000 divided by 3 into 7 is 47, and the element which is divisible by 5 and 7 is 1000 divided by 5 into 7 is 28. And the element which is divided by 3, 5, 7 is 1000 divided by 3 multiplied by 5 multiplied by 7. Okay, which is 9. So all above all these values replace into our principle of inclusion and exclusion. Coordinate of A union B union C, which is coordinate of A, coordinate of B, coordinate of C. Replace all these values here. 333, 200 plus 143 minus coordinate of A intersection B, which is 66, A intersection C is 47, and B intersection C, which is a 28, plus coordinate of A intersection B intersection is C, which is a 9 over here. Okay, so find out all these calculations, you will get the 543 total. That means the number of integers which divisible by 3, 5 and 7 is a 543. But in our example, what we want the number of integer which is not divisible by 3, 5 and 7. Okay, what we want, the number of integer which not divisible by 3, 5 and 7, which is not divisible by 3 nor by 5 nor by 7. Okay, that means the number of integer 1000 minus the number of integer divisible by 3, 5, 7. Okay, the number of integer which is divisible by 3, 5, 7. Okay, you have to take it away from 1000. That means we are taking complement. Okay, complement from our universal set. That means 1000 minus 543. So 1000 minus 543, you will get the 453. 7. Okay, that means the number of integer which is divisible, which is not divisible by 3, 5 and 7 is a 5, which is the 557. Okay, this is 557 required answer. See guys how easy the question is. So if you want guys, you can refer this entire solution from here. Okay, so first of all you need to know the formula, only then you can define the remaining values. Okay, so define these values, replace into the formulas, you will get the number of integer which is divisible by 3, 5 and 7, but we want which is neither nor divisible by 3, 5, 7. So I removed that divisible by 3, 5, 7 from 1000. I got the 457 which is a integer not divisible by 3, 5 and 7. Okay, I hope guys you all have understood this example. It is very important example guys. Maybe you will get the similar kind of the examples in your question paper. It is not that difficult, but we need a practice. Okay, so I hope you all have understood guys my today's lecture. So for similar videos guys, let me know in my comment section. I will come up with the videos. So thank you everyone, thank you for my today's lecture.